Yo, 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 yo. Alright, guys. This is the last video for Module 8. And we're just going to talk about special types of systems of equations. So, we have been solving systems with one solution for the most part. Okay, so when we solve a system of equations, there's where they intersect. So that's when we learn how to graph lines. And if I had like a line here and a line here, this point is the solution to that system. It's where the two lines intersect. That means that there's just one solution to this point. This is what we've been doing. So there's an x and a y that is true for both of the equations, and it's on both lines. That's the type of equation that we've been, those are the systems that we have been solving. Today we are going to look at systems with no solution and systems with infinitely many solutions. No solution means that the lines are parallel. So again, if I'm graphing, it's when I have this line here, but then I have another line down here. They're never going to cross because those are parallel lines. That means they don't have a solution. There is no combination of x and y that works for both equations. Infinitely many solutions is when we graph a line. Let's say I graph this line right here, but then when I graph my second line, it ends up being the same exact line. So that means that every single combination for x and y would work. So there's infinitely many solutions because they are the same line. But we're going to talk about no solution and infinitely many solutions when solving by substitution. Okay, so we're going to look at it when solving by substitution. So here I have a system of equations that I want to solve by substitution. I'm actually not going to graph it. I guess I can. So first of all, if we're going to solve by substitution, we have to figure out what variable we want to solve for. I can solve for negative x, negative y, x, or y. Well, I'm going to solve for this y right here. I don't want to solve for this y or this x because they're negative, so that's just a little bit extra work. So let's solve for a positive variable with no coefficient. So if I want to solve for this y, I can do that by adding x, because negative x plus x is 0. And whenever I do on one side, I have to do on the other. So I get x plus 4. I can't combine x and 4, so I just rewrite the whole problem. Now, this is in slope-intercept form, but I have a y equals right here. So I get to plug this in for y into the other equation. So now when I do this, I'm going to rewrite that top equation, but with my new y value plugged in. So that's x minus whatever y is. Well, y is x plus 4. And all that's equal to negative 2. So what happens here is, notice how we have this minus sign in front of the parentheses. I always make my substitution in parentheses. I'm just replacing this y with y here. That's how I do it in parentheses, but because I have a minus, that's minus everything inside the parentheses, so it's really x minus x. And that's also x minus 4. And all that's equal to negative 2. This minus sign is going to change the sign of everything on the inside. Now from here, I'm going to combine my like terms. Those go away. Because x minus x is just 0. I'm left with negative 4 equals negative 2. Now this is where we look back to our knowledge from solving equations before. Whenever our variables cancel all the way out and we're left with one side and the right is not equal to the right side, so if I'm left with no more variable and the left side and the right side are different values, that is an example of something with no solution. Okay, no solution means that they are parallel lines. So they have the exact same slope. So they have the same slope, but they have different y-intercepts. So now let's look at that on a graph. We already changed this first one to slope-intercept form. Let's change the second one to slope-intercept form. I can do that by subtracting x from both sides. I have negative y equals negative x minus 2. But because I have negative y, I don't like that. I got to divide everything by negative 1. And that gives me y equals positive x plus 2. So I look at the second equation, so the second one here, we change to this. That's x plus 4, start at 4, up 1 over 1. So there's the line. So this is the second line, and this is the first one. Notice how they have the exact same slope. The slope is still 1 over 1 for both of these. The difference is the y-intercepts. So they're going to change at the same rate, which means they're going to be parallel, and they're never going to cross. So that is an example of no solution. So if you ever have them in slope-intercept form, if you have two lines and two equations in slope-intercept form, so if I had y equals x plus 2, y equals x plus 4, I can tell right away that this is no solution because they have the same slope. If they have the same slope, that means it's either going to be infinite or no solution. If they have different y-intercepts, it's automatically no solution. If they have the same y-intercept, that means they're the same line, which means it'd be infinitely many solutions. Okay, so here's another example. We don't know elimination. We're gonna continue to solve by substitution. So I can subtract 2x from both sides, subtract 2x from both sides. Whoops, I subtracted it from, there we go, subtract it over here. The reason I'm subtracting 2x is I'm solving for this y, because this doesn't have a coefficient in front. That goes away. I get y equals negative 2x minus 2. And again, we can't combine these because one has x, one doesn't, so that's it. Okay, so this becomes this. Now I have something that I can plug in for y. So I'm going to rewrite everything, but I'm going to make a substitution in for y. Well, I'm substituting negative 2x minus 2. Now I have to do my distributive property. 2 times negative 2x is negative 4x. 2 times negative 2 is negative 4. Bring down my 4x equals negative 4. A lot of 4's here. But let's simplify the left side. 4x minus 4x is 0. Those cancel each other out. I'm left with negative 4 equals negative 4. So my variables canceled. The left side and the right side are the exact same thing. This would be an example of infinitely many solutions. Okay. They are the same line. So what we're going to do here is we want to solve each one of these systems. And we want to do so by figuring out how many solutions each system has. So we're going to figure out, is there one solution, is there many solutions, infinitely many solutions, or is there no solution? I'm going to tell you what variables I want you to solve for. I want you to solve for this x, and then let's solve for, this one's kind of tough. Let's cross off number 8. I don't want to do number 8. Okay, so let's just solve for these two x's. So plug them in. Simplify. So I recognize that this x has a number in front. That's okay. That means we're going to have to do some division. It is what it is. It's going to be fine. Okay. So we're going to have to do some substitution. Okay. So go ahead, solve for x, solve for x, plug them in, see what happens. So pause it, try it, see how you do. So if I solve for this x, I got to subtract 3y from both sides. That goes away. I'm left with negative 2x equals negative 3y plus 4. Now I got to divide by negative 2, and I got to do it everywhere because I'm trying to get x by itself. Negative divided by negative is positive. I can write this as 1.5 if I want, because 3 divided by 2 is 1.5. And that's going to be minus 2. I could also write it as 3 over 2. It doesn't really matter. Decimals are okay. Now I have something I got to plug in. This is why we're allowed to use calculators, right? And I got to plug it in for x in my top equation. That's 4 times 1.5, y minus 2, minus 6y equals 9. Now I have to do 4 times 1.5. This is where those calculators come in handy. Okay, so 4 times 1.5 is 6. So that's 6y. And this is going to be 4, negative 2 is negative 8, minus 6y equals 9. Well, 6y and negative 6y cancel out. Negative 8 equals 9. That means that there is no solution to this equation. Second equation right here, solve for x. So we're going to subtract 2y from both sides. Those cancel. I'm left with x equals negative 2x plus 6. Okay, I'm sorry, negative 2y. That was a y, not an x. What am I doing? I subtracted 2y from both sides. So now I have something that I can plug in for for x. I can plug in negative 2y plus 6 for x in the second equation. So that's 2 times whatever x is. Well, it's negative 2y plus 6 minus 3y equals, what was that number? 26. Well, distributive property. Negative 4y positive 12 minus 3y equals 26. Right away, I should be able to see, because negative 4y, negative 3y makes negative 7y. So my variable does not cancel out. That means that there is one solution to this equation. There's going to be one solution. It's going to be a point, and I got to figure out, well, what is that point? So this is where I got to continue to solve my equation, and I get y equals -2. Now that I get y equals -2, I got to take it and plug it back into any of these y's. It doesn't matter which one. I'm going to choose this one because that one looks really easy. Because that's -2 times -2 plus 6. 4 plus 6 is 10. So I get x equals 10, y equals -2. So this one has one solution. This is the only combination of x and y that work for these two equations, and it's 10, -2. Okay, so that's it. Things to remember. Okay, if we get left with something like -2 equals 3, that means no solution. If we're left with 3 equals 3, that means infinite solutions. Okay, you have your independent practice. Try it out, see how you do, and that's it. Hope this video helped. If you guys have any questions, let me know. Gordias out.